Right, ladies and gentlemen, welcome back. If we remember from yesterday and the day before, we talked about the Pythagorean theorem. Okay, the Pythagorean theorem dealt with triangles, right? We had two legs. We had a leg here and a leg here, and our longest side was our hypotenuse, which was opposite our 90-degree angle. What we solved, or what we figured out when we played around with it a little bit, is we figured out that a squared plus b squared is equal to c squared, right? And in words, these were our legs squared. We made legs off of, or we made squares, off of our legs. And we made a square off of our hypotenuse. And we saw that the sum of the legs squared is equal to the hypotenuse squared, right? And that's where we get our equation, our Pythagorean theorem. Now, yesterday, we looked at how to solve for C when given A and B. When I was given two legs, we figured out yesterday how to solve for our hypotenuse. Well, today, we're going to look at how to solve for a missing leg, given one leg and the hypotenuse. So first things first, write down our equation. Write down our a squared plus b squared equals c squared. Now, the next smart thing to do is to label our triangle. Label A, B, and C, because sometimes it's easy to get confused. Best way to do it is to label our C first. And we remember this 90-degree angle. This 90-degree angle points to my hypotenuse, or my C value. So when I rewrite this, I'm going to substitute in 20 for C. So I'm going to write 20 squared is equal to, and then here it doesn't really matter which is A, which is B. I'll label 8 as A, and this question mark, this missing side, as B. So that's fine. So I'll plug in 8 for A over here. So I'll plug in 8 squared equals, we still don't know what this one is, B squared. Fine. When we simplify this, well, 8 squared, 8 times 8 is 64. Plus, we can't do anything with b squared yet, so we rewrite that as b squared. And then 20 squared, let's see, 2 times 2 is 4. A couple zeros, we get 400. Okay, so 64 plus b squared equals 400. Well, I want b all by itself. Right now I've got the 64 on this left-hand side being added to b squared. I want to get rid of that. So because this is positive, is being added, I need to subtract this. I need to take away this 64. But I can't just do that to one side. If we remember, we've got to do it to both sides. Like so. And those 64s cancel out, so I'm left with b squared on this left-hand side is equal to 336. All right, and if we remember from yesterday, this is where things get a little bit interesting. To get rid of this square, because I just want b by itself, to get rid of that square, I take the square root. So I take the square root of both sides. So I take the square root of both sides, looks like that. These two cancel out, so I'm left with b. If we remember in our calculator, we'd look at the square root, we press second, and then in blue right there, right above x squared is that square root. So because we're in the second function, we press x squared, and we get that square root, and then we type in 336. 336, so the square root of 336 gives me 18.3. If I'm rounding to the nearest tenth. 18.3. Okay? And so my missing side, there it is. Moving on to this one on the bottom here. Go ahead, try this one on your own. So pause the video, actually pause the video, and try this one on your own as far as you can get, and then go ahead and click play. Okay, so bare minimum, we should have a squared plus b squared is equal to c squared. And we should have our sides labeled. We know this is pointing to our c. So 25 is going to be c. And it doesn't much matter. We can call 15 b, and our missing side we can call a this time. Doesn't matter if you labeled this as a or this or b. It's okay. And so we plug that in. We get a squared plus 15 squared equals 25 squared. Fine. A squared, can't do anything with that. 15 squared, we get 225. And then 25 squared is 625. Okay? We should have at least gotten this far. Now from here, a little bit of algebra. We're trying to solve for a. So I've got this plus 225. Well, I want to get rid of that, so I'm going to subtract 225 from both sides. Subtract 225. A squared equals 400. And then what do I do here? Ah, yes, that's right. We take the square root of both sides. And then we get a equals 20. Great. Moving on, flip the page over to number 2. Again, pause the video. Try it on your own. See if you can get even further than you did last time on your own. Okay, so let's take a look at this. So we know, all right, a right angle pointing to our C value, or our hypotenuse. And since that's labeled B, we'll label this one A. So then A squared plus B squared equals C squared. Fine. C squared is 13 squared is equal to, don't know what B squared is yet, plus 12 squared. 12 squared, 144, plus B squared is equal to 169. And then, because I've got this 144 here, I need to take away that 144 from both sides. B squared is equal to 25. 6 minus 4, 2. 9 minus 4, 5. And now, remind me, what do I do here? How do I get rid of this square? Yeah, exactly. Take the square root of both sides. Square root of 25. Again, if you didn't know that, you plug that in your calculator. Second, x squared, 25, and we get 5. So B, that missing side, is equal to 5. Bada boom, bada bing. All right, last one, number 3. Do this one on your own. Pause it. I'm sure you can do this one all by yourself. Go ahead and do it. Great. Now that you're done with it, let's check your answer. So we've got a squared plus b squared equals c squared. Let's see, which side is our hypotenuse? Again, arrow pointing towards my c value, or my hypotenuse. Likewise, that's b. So this other one, a. Cool. So 4 squared plus b squared equals 11 squared. 4 squared, 4 times 4 is 16, plus b squared equals 121. I'm sorry, my b looks a little bit like a 6. I've been working on it, but not there yet. Subtract 16 from both sides. Subtract 16 from both sides. b squared equals, let's see, I got to use my handy dandy calculator, 121 minus 16 equals 105. And then take the square root of 105. And we get b equals, well, when I take the square root of 105, I get 10.2469 and so on. But it's telling me, okay, round to the nearest whole number. So let's see, I look at the place right before that whole number of 0. I look at that 2. All right, that 2 is below 5, so I'm going to stay at 10. So b equals, or is roughly, we could even make these little squiggly to say roughly or approximately 10. Okay? So go ahead and ask for the homework, the next note page, and show off what you now know.